Hi students. Now, previous video we have seen some important basic formulas of topic electrostatics. Now we'll start NCERT solutions for chapter 2, that is electrostatic potential and capacitance. So we'll start with the first numerical. Consider two charges. First charge 5 into 10 raised to 8 minus 8 coulomb and minus 3 into 10 raised to minus 8 coulomb are located 16 centimeter apart. At what points on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. So, my dear student, here we have to find at what distance or at what points on the line joining the two charges is the dielectric potential 0. So first we'll consider the given things. There are two charges. Charge first, the magnitude of charge first is 5 into 10 raised to minus 8 coulomb, and the magnitude of second charge is minus 3 into 10 raised to minus 8 coulomb. Now, as per the given quantity, the distance between two charges is 16 centimeter. That is 16 into 10 raised to minus 2 meter. That is 0.16 meter. Now, for simplicity, just consider a point P. Here we can consider point P between the two charges. Here, as per the question, we'll see. Now, if you see here point carries Q1 charge, and here one more point which carries Q2 charge, and this small d is the distance between two charges. So as per the given condition, this small d is nothing but 0.16 meter. Now in order to find the electric potential, okay, where it will be 0, so consider two charges Q1 and Q2 at distance d, and now consider any point P at distance r from the first charge and distance this d minus r from the second charge. I repeat, this point P will be at distance r from this first point, and suppose if whole distance is d minus this r, so this will be d minus r distance from this Q2 charge. So here let the electric potential V at point B is 0. As per the given conditions, just we imagine that electric potential at point P is 0. Okay, then the potential at point P is the sum of potential due to fields of charge Q1 and Q2 respectively. Let me explain this sentence very clearly. If you calculate electric potential at point P due to this Q1 charge, it will be 1 upon 4 epsilon naught Q1, that is charge upon distance. So Q1 is the charge and distance r, so that we have written 1 upon 4 pi epsilon naught Q1 upon r. Similarly, if you find electric potential at point P due to this Q2 charge, that is second charge, we can write with the help of electric potential formula 1 upon 4 pi epsilon naught charge, that is Q2, divided by distance. So here distance is d minus r. So here one thing I want to explain you, my dear student. Electric potential, in order to find the formula for electric potential, it is always charge upon distance. And if you find, and if you see the electric field, in electric field formula, it is charge upon distance square. That difference you must understand. So this is the electric potential produced at point P due to first charge, that is Q1 charge, and this is electric potential produced due to second charge. So in order to find the total electric potential at point P, it will be sum of these two potentials. So we can write Q1 upon 4 pi epsilon naught R plus Q2 upon 4 pi epsilon naught D minus R. This is equation number 1. But as per the given condition, the electric potential P is 0. So we can write V0 in this second formula. So for simplicity, we can shift this term to RHS or LHS. So it will be positive. So it is here, it is positive, it will become negative now. Q1 upon 4 pi epsilon naught R. So if you transfer to RHS, so minus Q2 upon 4 pi epsilon naught D minus R. So here 4 pi epsilon naught will get cancelled. So Q1 upon R minus Q2 upon D minus R. So we know that first magnitude of first charge is 5 into 10 raised to minus 3. And magnitude of second charge is minus 3 into 10 raised to minus 3. So our distance is given Okay, means given means we have to find, and d minus r, but d is the distance between two charges given. D is nothing but 0.16 meter. So here we can write, instead of r or d minus r, we can write r as it is. So here d minus r, we can write 0.16 minus r. So here we put the value of d. So if you solve this, we will get the distance of this point P from charge Q1, this r. So r will be, after solving this equation, it will be 0.1 meter, that is 10 centimeter. So therefore we can say that point potential is zero at point located between the two charges at a distance of 10 centimeter from the positive charge. Means if you place point P at distance 10 centimeter this positive charge, are you getting my point? Then the potential will be zero, isn't it? And this 10 centimeter means this will be this 0.16, 16 minus 10, so this will be 6 centimeter. Means we can say potential is 0 at 10 centimeter from this positive charge and 6 centimeter from this negative charge Q2, isn't it? Now in second case we will consider. Now just imagine second case. So now let point P, where the potential is 0, be outside the system. Just imagine that the point P is outside the system. Outside the system means here Q1 and Q2 at distance d as it is, and now consider point P at distance s. Here it is s from point or charge Q1, isn't it? So the Q1 and Q2 distance is d, and P is at distance s from Q1, and P is at distance s minus d from Q2. This whole s minus d, so this distance will be s minus d. Okay, so similarly we can apply the formulas for electric potential. If you find the electric potential at point P due to this Q1 charge, it will be Q1 upon 4 pi epsilon naught into s, that is distance. Similarly we can find electric potential at point P due to this Q2, so it will be Q2 upon 4 pi epsilon naught s minus d, where s minus d is the distance, isn't it? So as per our condition, electric potential V is equal to 0. So equation 2 reduces. Same way we can solve. So this will shift to the RHS, so it will become minus. And if you solve this equation, because 4 pi epsilon naught, 4 pi epsilon naught, both the side it will get cancelled. So finally we will get the value of S by putting Q1, Q2 and D value in this case. So S will be 0.4 meter, that is 40 centimeter. So we can say, therefore the potential is 0 at distance 40 centimeter from the positive charge outside the system of the charges. So here we uh, succeed to find out at what points. So first point at distance 10 centimeter from Q1, and second point at distance 40 centimeter from the Q1 outside the system. So this is the solution of first NCERT equation. So these questions you will find in your NCERT book. Now we'll move towards our second question. This is very important question. Many times this question has come in CBSE board examination for 2 to 3 marks. Consider regular hexagon of side 10 centimeter has a charge 5 microcoulomb. So my dear student, whenever charge is given in microcoulomb, we have to convert it into coulomb. So how do we convert microcoulomb into coulomb? By multiplying it 10 raised to minus 6, isn't it? So 1 microcoulomb is nothing but 10 raised to minus 6 coulomb. So at each point, at each of its vertices. So once again I read, a regular hexagon of side 10 centimeter has a charge 5 microcoulomb as each of its vertices. Calculate the potential at the center of the hexagon. Means we have to calculate what is the electric potential at this point O. But we know that the given figure shows the 6 equal amount of charges. That is, if you see A, B, C, D, E and F, all are having 6 equal charges. That is, magnitude are equal. Each and every charge, that is 5 microcoulomb, that is 5 into 10 raised to minus 6 coulomb. And if you see the distance between A and B, B and C, all distances are equal, and that distance is given by 10 centimeter. So if you see the geometrical things, OB is equal to OB. If you complete this parallelogram, OB or OBCD, this DO. So here it is very clear that OB is parallel to CD. So CD is 10 centimeter. Okay, so OB also 10 centimeter, means this point charge O is equal, means equally placed from all this, or we can say this center is equally placed from all this point charge. that is 10 centimeter. So by using simple formula we can calculate electric potential. Electric potential simple formula is there. Electric potential V is equal to K, that is 1 upon 4 by epsilon naught into charge upon distance. So here charge they have given 5 into 10 raised to minus 6 and distance everywhere it is 10 centimeter, that is, so we can apply this formula. 10 centimeters nothing but 0.1 meter. So K is nothing but 9 into 10 raised to 9, okay, into this charge 5 into 10 raised to 6 divided by 0.1. But don't forget, my dear student, this point charge is 6 times, that is 6 charges are there, A, B, C, D, E, F. So we have to multiply by 6 over here. So we rearrange the formula. 6 into 9 into 10 raised to 9, 5 into 10 raised to minus 6 divided by 0.1. So the final answer will be 2.7 into 10 raised to 6 volt. Therefore, the potential at the center of the hexagon is 2.7 into 10 raised to 6 volt. So hope you understood this second numerical also. Now third numerical we'll see. Look here. So third numerical, 2 point charges or two charges. First is having 2 microcoulomb and second is having minus 2 microcoulomb, are placed at points A and B 6 centimeter apart. Then identify an equipotential surface of the system and what is the direction of the electric field at every point on this surface. So in order to solve these numericals, my dear students, it is very clear that if you find the equipotential surface, a surface at which potential remains same at each and every point, it is known as equipotential surface. And in order to find equipotential surface for this given surface, the equipotential surface selected may be plane located at the midpoint of AB. If you see the equipotential surface for uniform electric field, it is already given. If you see the previous expression, so it is given. So here we can draw the plane, any plane we can draw, and inside the plane at each and every point the potential will be same. So in order to find in other point, we can say on this plane the potential is 0 since all points on the plane are equidistant from the two charges. And as we know, electric field lines start from positive charge and end with negative charge. So direction of electric field is always from A to B, that is AB. So this is very easy numerical. It may come for 2 marks. Then we'll turn towards the fourth numerical. The spherical conductor of radius 12 centimeter. We have spherical conductor of radius 12 centimeter. Charge उसके ऊपर है 1.6 into 10 raised to minus 7 coulomb and distributed uniformly on its surface. What is the electric field? Inside the sphere, just outside the sphere, and at point 18 centimeter from the center of the sphere. So my dear student, we know that radius of the sphere of conductor is a spherical conductor is 12 centimeter, that is 0.12 meter, and charge is uniform distributed is 1.6 into 10 raised to minus 7 coulomb. But as per inside the sphere, we know that inside the sphere there are no charges, so electric field inside the sphere is always 0. If you turn towards second, if you use simple formula, electric field, as I said, is nothing but K 1 upon 4 by epsilon naught into charge upon distance square. So charge they have given 1.6 into 10 raised to minus 7 and distance is 12 centimeter, radius is 12 centimeter. So E just outside means equal to the radius here. That thing you have to consider. Electric field E just outside means nearly equal to the radius. So distance will take same 1.6 into 10 raised to minus 7 coulomb only. So where K is equal to 1 upon 4 by epsilon naught and epsilon naught is permittivity of free space. So if you put formulas, K is nothing but 9 into 10 raised to 9, charge 1.6 into 10 raised to minus 7. So distance as you have considered E just outside, the distance is equal to radius, so 0.12 square. So if you solve all these quantities, electric field just outside it will come 10 raised to 5 Newton per coulomb. So now third question, at a point 18 centimeter from the center of the sphere. So if the radius is 12 centimeter, so we have to calculate 18 centimeter. 18 centimeter means just outside. So we'll take the distance 18 centimeter. So this is very simple. You put the values as it is. So charge is given 1.6 into 10 raised to minus 7. 1 upon 4 by epsilon naught is nothing but 9 into 10 raised to 9. And distance square, distance is nothing but 18. Already it is given. So 18 centimeter, that is into 10 raised to minus 2 meters. And as distance square is there, we have to do square. So if you solve, so it will come 4.4 into 10 raised to 4 Newton coulomb. So this is all question. Inside the sphere, electric field is 0. At outside the sphere, it is 10 raised to 5. and at a point 18 centimeter from the center of the sphere it is 4.4.